Hey guys, I'm Jay. Today is my LeetCode review vlog on the 42nd problem, trapping rainwater. We are given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. And here's the example 1. The output should be 6 because there are 1, 2, 3, 4, 5, 6 water block that we can trap in this input array. And then let's get started quickly. The first is the intuition for the problem. So the intuition is there is a very insightful hint we can get is to understanding that the water amount we can trap trapped water amount is the minimum of the tallest bar to its left and right minus the height of the bar itself. Let's see our example here, which is the minimum of the tallest bar to its left and right minus the height of the bar itself. For example, the block here, so the left max bar is 2 and the right max bar is 3. The height of the right max bar is 3 and the minimum of them is 2 and the height of the bar itself is 1. So 2 minus 1 equals 1. So for the 1, 2, 3, 4, the fourth position, you can trap 1 rain. And that's the key point that we should remind. And among the solution, let's say we can use a two-pointer approach. We will start from both the left and right end by maintaining 2 pointers left and right. If the smaller height it is at the left end, water trapped would be dependent on the tower's height in the direction from left to right. Otherwise, it is in a reverse situation. So let's get started with our code quickly. The first part is we have to initialize several variables to help us to solve the problem. Let's say we can have a left equals 0, which means the left height so far, and we can have a right pointer pointing to the last element. It could be height dot length minus 1, and we can have a left max variable. It will recording the maximum value of the height from left so far, and we'll initialize variable with height of left. As we all know, there is another tips we should notice. The start and the end element cannot trap any water. Definitely, as we can see here, no matter how tall the start and the end element is, it can trap any water. So we can directly initialize the left max with height of left, and the left is 0, and the right max right max variable can be initialized with height of right, and right is the index of the last element. And then we are creating answer variable started at 0. Then we can create a while statement, and the expression is when left pointer is less than the right pointer. If the condition is true, we can keep our iterating. And inside the while statement, the first step that we have to check is the minimum. Check the minimum of the tallest bar to its right and to its left and right. So we have to check for left max and right max. If left max is less than right max, we have to take minimum, which is left max, and compare left max to the height of the current position. So the first part is the first step is we have to increment left. As left it is still 0, and left max has already recorded the height of the zeroth element. So we have to increment left pointer to point to the first element. Then we have to up the left max with the maximum value of left max itself and height of left. We have to choose the bigger one, and we have to update left max after each iteration. And the final step is we have to check how many waters we can trap in the new position, which is answers plus would add the value of left max minus height of left. And don't be worried, this expression won't be negative as we have already updated left max. So left max holds the biggest value so far. So it won't be negative. And the baddest case is 0, so it won't affect our answer, the correctness of our answer. And if the value of this expression is positive, which means this position can check or can trap amount of water here. On the other side, if left max is bigger than the right max, we have to do it similarly. Oops. The first step is we have to decrement right pointer, and we have to update right max with the bigger value of right max itself and height of right. And then we have to update answer. We have to add the difference to the answer variable, right max minus height of right. And after the end of the while statement, we have to return the value of answer. Let's check for the correctness of our code. Yes, it is got accepted. Then let's analyze the time and space complexity. The time complexity is obviously big O of n, and n stands for the length of the inputted age height array, as we only traverse the height array for only one time with the while statement, and the space complexity, it is big O of 1, which is a constant, as we only create several constant number of variables to solve the problem. And thank you guys for you watching. This is the end of my LeetCode review vlog for the trapping rainwater problem. You can also check for the detailed notes for this LeetCode review problem on my GitHub repository here. I'll put the link in the description of my YouTube below. And thank you guys for watching. See you next time.